This one's going to be kind of a stretch as we talk about graphs of revenue and expenses. I wanted to start with this GIF because we're going to start to visualize where our money is going when we make a product, when we sell a product, and at what point it makes the most sense to say, all right, we want to make 200 widgets or 300 widgets because we'll get more revenue and that'll overpower our expenses. This is a really silly GIF from the TV show Tim and Eric, if you've seen it before. The premise is that this is a game show where they're just giving out money to these celebrities. And it's kind of interesting because you just keep throwing out money. And at some point, people might get it or don't get it, or maybe they lost money. I mean, look at that number. That's a big number. I don't know. But I kind of thought this would be a funny way to start because we're visualizing how much money is being spent and how much of it we might have left over, if any, or if we're going to make a profit or not make a profit. In this case, this is just giving away money, so you probably lost money. So take one more look at it and laugh because I think this show, Tim and Eric, awesome show. It's from forever ago, but pretty funny. The actual clip's on YouTube if you want to watch it, but yeah, kind of a stretch. If that's up your alley, awesome. But visually, we're going to be assessing what it looks like when we're spending money, when we're trying to make widgets, when we're trying to cover expense costs, when we're trying to maximize our revenue. And we do that with graphs. So the graphs is a way that we can show the correlation between revenue and expenses. Okay, so as we dive into an example, a particular item in the Picasso paints product line costs $7 each to manufacture. Ooh, so this means that it's a cost per widget, or in this case, per item. So when they say particular item, I'm thinking of that as the widget. And the fixed costs, so what we have to pay no matter what, are 28,000. The demand function is Q equals negative 500 P plus 30,000, where Q is the quantity the public will buy given the price P. So this isn't going to a manufacturer. This is going straight to the public. That's interesting. Graph the expense function in terms of the price on the coordinate plane. Well, we know that the expense function we can create because, again, this $7 is our fluctuating variable. And we have the fixed cost of 28,000. So we could create this equation for our expenses. And what are we doing here? We're substituting for Q to find the expense functions in terms of price. So in terms of P. So, all right. I see that Q could be represented as all of this negative 500P plus 30,000. So if I put that in place of Q, I'm doing what they asked. They want terms of price, so I would only be left with terms of P. So let's rewrite that. E is going to be equal to 7 times that negative 500 P plus 30,000. There's nothing else we need to add in there. Okay, so that's everything. We also have the 28,000. Don't forget it because that's left over when we're talking about expenses. What can we do to take this further? Hopefully you're saying that we can distribute the 7 into both of these terms, getting negative 3,500P plus 7 times 30, so 210,000. And then don't forget the 28,000 down here. Can we simplify this further? Hopefully you're saying yes. So if we do that, we get negative 3,500 with a variable of P, and we're adding on now 238,000. And this is now measuring our expenses in terms of P. And the reason that we're doing this is because eventually we're going to try and map out our expenses based off of our revenue. You know, we're not trying to lose money. Breaking even, we can accept that sometimes, but we're trying to get all that revenue up. We're trying to not make a ton. We're trying to be strategic with how much we make and maximize how much money we can really bring in. So this equation is going to be a really important part moving forward. And recall that we can kind of use X and Y interchangeably. So if we wanted to graph this out, you could call this Y1 and you can call this X if you're using your calculator or Desmos to graph this, which we soon see makes sense, would be a linear line. You might be wondering how we got these points here. Okay, so it really comes down to getting two things, your y-axis and your x-axis. So think of this the same way you have in algebra when you get this. So if I wanted to get the y-axis, and I should say y-axis intercept, the y-axis intercept's just hanging out right here. So this means that if I don't sell anything, I don't even bother with the negative 3,500. No matter what, I have to pay this 238,000. So we know that our y-intercept would be 238,000, which makes sense because that's graphed out here. And then for our x-axis, we have to do a little bit of work to get that, but it's pretty manageable because we can just plug in, instead of P, we plug in for E. So to get our now x-axis, I'm saying I want E to be 0. And then I'm rewriting this. And I'm solving for P now. So isolate your variable P. Get rid of the 238,000. You don't need that. Subtract it from both sides. A little bit of algebra, nothing you can't handle. This should then leave you with negative 238,000. And remember, this is equal to a negative 3,500p. So what can we do further to solve for P, for the price? Hopefully you're saying divide by negative 3,500. I'm soon not even going to bother writing out this two-step equation because I'm hoping you would just understand how we get there. But eventually, if you simplify this, this should give you 68 for P. So this is saying that we have a y-axis, sorry, y-intercept for $238, because remember, we're measuring there. And then 68 for P is on the x-axis. And so we just drew a line between the two. Does that make sense? Okay. So if you want to check your understanding, you can try this one out. If you're watching through Edpuzzle, I'm gonna have that one be an option for you to watch. So pause it, try it, and I'll have the answer there so you can check your work. What's the revenue equation for the Picasso Paints product? Write the revenue equation in terms of the price. Okay. Well, we know that the revenue is going to be our price times the quantity that we sell. Okay. And we know, well, which of these variables do we know? Do we know P or do we know Q? Which one do we know? Which one? Do we know P or Q? Way up here, they gave us Q as negative 500P plus 30,000. So let's borrow that because we already have it. I don't know P, but that's okay. Too much. So in here, I know that Q can be rewritten, but I have P on the outside. So this is negative 300P, sorry, 500P plus 30,000. And then what can I do with my variable of P? Hopefully you're saying distribute it. Let's be then negative 500 P squared plus 30,000. Time to go to your next class, just kidding. And so this is now something we could map out. Can we do that? Yeah, we can. Side understanding, if you wanted to check if this was $25, what could you do? The revenue, if your price per set's $25, what can you do? Try that out. We can then graph this. And the main thing that we're looking for here is the highest point because, you know, revenue, it's most likely going to go up and the highest point's what we want. So ideally at some point, you know, if we're charging too much or we're really exaggerating what something's worth, then we might not maximize how much revenue we want. So we're going to use something from Algebra 2, should look familiar. It's negative b over 2a. Since we're working with a term being squared, we want to focus in on what's called our axis of symmetry. So again, the highest point would be our max here. And we don't really want to bother graphing this out. We just want to know what's going to get us the most amount of money. So if we use negative b over 2a, where our a coefficient is this negative 500, our b coefficient is this 30,000. If we plug in accordingly, we have negative b, so negative 30,000, and this is all over 2a, so 2 times negative 500. Don't forget there's the 2 in front. So this is eventually, when you simplify it, just going to be positive 30. Okay, and so when you graph this out, this is saying that when your price is 30, that's going to be the highest point of your revenue. Because remember, we're mapping out revenue. And if you're so curious, we could find out exactly how much the revenue is going to be, which is 450,000. So occasionally this gets put down as an XY point, like an ordered pair, so be open to that. Let me make this a unique one. So this was representing P. This was representing our revenue. So be open to that ordered pair type bit. But we see that if we charge $30, the maximum revenue we'll have is 450,000. So sometimes this is helpful when you're framing on a calculator what you need it to look like. When asked which price would yield the higher revenue, 28 or 40, that's something interesting. I'm going to guess 40. It's like, I'm going to guess 28. 28 is closer to the maximum. So I would guess 28 is going to be the higher revenue because it's closer to the axis of symmetry, or the maximum point if you'd like. The revenue and expense functions are graphed on the same set. The points of intersection are labeled A and B. So recall this line, the linear one, was what we already did. Remember that up here, this was 238,000. Was it? It was some number. I think over here it was 62, right? 62 or 60. It's going to kill me if I don't get this right, actually. So let me just back up and check it. 68 and 238,000. Okay. Okay. So this was 68, which makes sense. It's a little bit past the 58.92. And this was 238K. And so what can we take a look at now? We have a little bit of information we can look at here. Well, the break-even points, this means that we're making just enough of the quantity to break even, where we don't lose money, we don't gain money, we just broke even. You know, we're not always aiming for that, but sometimes we do if we're trying to get rid of some old product that's not moving. So here we have 2 break-even points of this 8.08 and also 58.92 for the pricing. So how could we come across this? You could see where they intersect.
Maybe this is where it says, don't we have a class now?
After lunch, so 11:25.
Is lunch right now?
Mhm.
Right.
Yep. So the break-even points are those 2 points. So boom, there you go. 2 points where we would break even. Again, we're always aiming for more revenue than expenses, but that helps. And that's it. So the one question here is asking, why is using the prices of 750 and 61 not in the best interest of the company? Well, 750 is around here. And that would be saying that our expenses are greater than the revenue. So at 750 is considered a loss. We lose money. Whereas if we look at $61, that's potentially the same thing where, I don't know, we might not even make any revenue if we charge 61. So at $61, it's the same kind of thing where our expenses are definitely greater than the revenue. So if we charge a ton of money, like $61, we still lose money. So there's a lot that we can look at here. We see that we're graphing linear lines, we're graphing parabolas. So using the calculator to help you out there should help. We meet at 11:25.
Oh, yeah.
You got lunch now.
Oh, okay.
Yep. Hope that this video was helpful. If you have any questions, holler, let me know. Thanks for watching.